45 years, 24 billion kilometers, 160 bits per second. The loneliest probe of humanity. How did a 1970s technology take pictures of Earth? What would Voyager 1 see if it turned on its camera now? Here comes the science. This is the famous image taken by Voyager 1. Our Earth, 6 billion kilometers away, appears as a tiny pixel. When this photo was taken, you might not have been born yet, but all the elements and substances that make up all of us are contained in this tiny blue dot we call home. However, this date is significant. 34 minutes after this photo was taken, the camera was turned off forever. Voyager 1 has been completely blind since then. Since then, this spacecraft has become the farthest man-made object in space, now 24 billion kilometers from Earth. But why was the camera turned off? And what would it take to turn them on again? In this video, we will explore how the cameras on Voyager work, and what it might see if they were turned on again. The Voyager space probes, during their time in space, have broken numerous records. They are not only the farthest objects in space, but also the longest-running objects, for over 45 years. Incredibly, after years of exposure to the harsh environment of space, the computers and systems designed on Earth in the 1970s are still functioning. Voyager 1 was equipped with cutting-edge technology at the time, and a perfect example is its camera system. Voyager 1 has two Vidicon cameras, essentially very early television cameras, using analog to digital technology. Their effective resolution is 800 by 800 pixels, capturing 8-bit grayscale images. One is equipped with a wide-angle lens, used to capture the complete details of planets when the probe makes a close flyby. The other is equipped with a narrow-angle lens, which can zoom in to capture smaller details of each planet it observes. Sure, we can still look back at our shrinking solar system. However, before the light reaches these cameras, it passes through an optical system that enables it to form color images. This is a filter wheel containing purple, blue, green, and orange filters. Voyager will use each filter to take multiple shots of the subject. When the light passes through the filter, only the light of that color is allowed through, while the light of other colors is absorbed. The images are still taken in grayscale, but each image will have areas of different brightness. The light is more sensitive to a certain color. Once these images are sent to Earth, they will be saturated with the color of the corresponding filter and combined into full-color images. This is basically how the human eye works, because the human eye has three color-sensing cones: red, green, and blue. They combine to provide us with a variety of colors. But for Voyager, the real magic happens inside the Vidicon tube. After passing through the lens and the filter wheel, the light enters the Vidicon tube. The first thing the photons hit is a transparent mask plate made of a layer of silicon oxide. Immediately after is a light-conducting target plate. When the photons hit the target plate, they release free electrons. The higher the intensity of the light at a given point, the more free electrons are released. These free electrons are then attracted by the mask plate, leaving gaps on the target plate. After that, a cathode at the back of the tube emits electrons to scan the image. When these electrons reach the target plate and fill the gaps, a current is generated. This signal contains image data and can now be transmitted back to Earth. However, transmitting data from billions of kilometers away is very difficult and can cause many problems. How does Voyager 1 send data back to Earth? We have seen how Voyager's camera converts light into a signal, but what happens next? Each image taken by Voyager 1 occupies approximately 5 million bits of information, or a little over half a megabyte. By today's standards, this doesn't sound like much, but when your spacecraft is billions of kilometers away from Earth, sending this data back is extremely difficult. When Voyager 1 was still relatively close, its maximum data transmission rate was about 115,000 bits per second. At this rate, it would take about 43 seconds to send an entire image back to Earth. Now, the data transmission rate is only about 160 bits per second. This means that it takes over 8 hours just to transmit one image. In addition, Voyager 1 is now 24 billion kilometers away from Earth, so the signal actually takes 21 hours to reach us. Because the camera generates images much faster than the data can be transmitted, the signals from the Vidicon camera are stored on magnetic tape. These data accumulate over time and can be transmitted when communication between Voyager 1 and Earth is good. But why haven't Voyager's cameras been turned on for over 30 years? To answer this question, we need to look at the position of Voyager 1 when it took its last photo. The famous pale blue dot image was taken from a distance of 6 billion kilometers from Earth. At this point, the spacecraft was so far away that everything looked like tiny dots. The spacecraft was also on its way to becoming the first to leave the solar system and enter interstellar space. To know when this moment would come, the team hoped to give priority to using an instrument capable of detecting interstellar plasma. This is the Voyager 1. It is a sign that it has left the solar system. But at that time, Voyager 1 was already 13 years old. It still needed several decades to reach interstellar space, therefore. To maintain contact with the spacecraft at that time, engineers needed to significantly extend its lifespan. Like many spacecraft, Voyager 1 is powered by a radioisotope thermoelectric generator, RTG, which converts the heat from radioactive materials into electricity. Its power output decreases by about 4 watts each year. Currently, Voyager 1's power output is only 57% of its initial power. The camera system itself consumes over 40 watts. Therefore, to give the spacecraft more time, the team began to shut down various instruments on Voyager to reduce its power consumption. To save memory, the team also deleted the software responsible for operating the camera. The computers and software used on Earth to analyze the images no longer exist. Moreover, due to the camera and its heater being exposed to harsh conditions in space for decades, they are likely no longer functioning properly. But if the camera is still in good condition and reactivated, what would it see? Many people think that Voyager 1 is so far from the Sun that it would be in complete darkness. But this is not correct. Even though it is now 24 billion kilometers from the Sun, the brightness of the Sun is still 16 times that of the moonlight on Earth, bright enough to read a book. However, there is nothing interesting or large enough around for Voyager to capture. If Voyager took a picture today, it would be dark, but you would still see the Sun and some planets as faint pixels. Perhaps the most astonishing thing is that despite traveling 24 billion kilometers, the constellations in our sky would look exactly the same. If Voyager wanted to obtain a different perspective of our galaxy, it would need to travel thousands of light years to see the slight displacement of the stars. Voyager 1 will eventually achieve this, millions of years after we are gone and long after we lose contact with the spacecraft. This is Voyager 1, a lonely and great explorer, constantly moving forward in the long river of the universe, carrying the hopes and dreams of humanity.